and I need you to pay attention. I've done this in class before. Take a look at question part 1. Let x1 and x2 be independent with normal distributions. Whenever they give you something in this way, you know what I'm trying to tell you? Okay, mu1, 6. Okay, sigma 1 squared, 1. Okay, and mu2 is like they've given you mu2, and so if you take a look at x1 and x2 be independent, it means this guy is for the x1 and this guy is for the x2 because they mention respectively. Does that make sense? And at times you can see that in listing form. Now the question now said, find the probability of x1 greater than x2. Okay, the probability of x1 greater than x2. X1 and x2 follow normal distribution. They got different means, but they have the same variance. One has a mean of 6, the other one has a mean of 7, but they have the same variance, 1, 1. Yeah, I need to take a look at that. Now you know what you need to do. When they say x1 greater than x2, now you're going to be thinking for a way to convert that to linear combination. Okay, now you're going to convert that to linear combination. Now, please, I need you to pay attention. Do you know if you attend my review for today and tomorrow, and you master this review, at least you will score 90% in this final. Let's say you don't want to read any other thing. You just want to focus on the review that I want to do today and tomorrow. You will score at least 90. And that's why I needed to pay attention, because I want everyone to pass. Now, you want to find probability that x1 greater than x2. Okay, what you need to do, x1 minus x2 greater than 0. That's another way to interpret that. Right now, this has become a linear combination, which means this guy is now a random variable. Maybe I can call that W, so that I'm going to say the probability of W greater than 0. And if this guy is a random variable, then I want to find the probability of Z score, which is going to be greater because I got a greater. Okay, the W minus the mean of W divided by the square root of the variance of W. Okay, take a look at my interpretation right now. Okay, now here I'm going to plug in 0. Then I need the mean. If you want to find the mean, so you need the expected value of W is going to be expected value of x1 minus x2, which is going to be expectation of x1 minus expectation of x2, which is going to be mu1 minus mu2. Then the variance of W is going to be variance of x1 minus x2, and they told you they are independent. There's no covariance. Okay, so here is going to be variance of x1, okay, whether minus or plus variance of x2, which is going to be sigma 1 squared plus sigma 2 squared. Look at that. Now, I needed to pay attention right now. Pay attention right now. Okay, now, this is what I was saying. Now, do you know what this guy is telling me? It's saying, when I use the formula here, I will get my mean to be -1 for that. -1. Let's see. If you go back, it's trying to say mu1 minus mu2, right? Mu1 minus mu2. What does that mean? That would be 6 minus 7. 6 minus 7. So 6 minus 7 is -1. Does that make sense? Okay. Now, what about the variances? This is telling you hard the variances, right? Hard the variances. 1 plus 1. That would be 2. And that was why we got -1 and 2. So -1 is for the mean and 2 is for the variance. Now, the moment I got that, I'm ready to go now. Take a look at what I'm doing now. Okay. Now, x1 minus x2, that will be 0. The top is 0 here. So you're going to put This is going to be 0, okay, minus the mean. That's why you see this one, then it's going to be 1. Then I said the square root of the variance. The variance was 2. That would be square root of 2. Now, this is what I got, 1 over square root of root 2. Now, if you get 1 over square root of root 2, okay, because we're dealing with the greater than, and when you want to check from a normal table, it's less than, then because of that, you're going to do 1 minus whatever you check from the table, from the normal table, and in the end, this is the result. Any question? In the end, that is the result. You convert it to linear combination, and that will be super cool. Okay? So take a look at that. Now, I'm going to go to the next question. Part 2. This is the way you're going to see part 1, part 2. Okay, the part 1 now handle linear combination. Part 2 is going to be centered on bivariate normal. Okay, now I need you to pay attention. Like I said, I'm going to do 1, 2, 3 problem today. Tomorrow is going to be the next 2 problems, and that will be online. Okay, tomorrow will be the last day that I'm going to appear with you, and I want you to attend the lecture from anywhere. Now, take a look at it. Let X, Y, I'm confirming to you one of the problems in the exam we centered on something that looked like this. So it's still going to be on normal. Of course, it's not going to be the same values. You get what I mean? And in the part 2, it's also going to look like stuff like that. Now take a look at it. Let X and Y have a bivariate normal distribution with the respective parameters. Okay, right now, they gave you rho correlation. In the first question that we did, because S1 and S2 are independent, rho is equal to 0. That was why correlation was not mentioned. Does that make sense? But right now, they're trying to tell you whenever a correlation is mentioned, then it means they want to go conditional. Does that make sense? Now, of course, I'm not going to say you should use R. Okay, disregard using R. I didn't teach R in this class. Now, the question said, find the probability of Y lying between 106 and 124. Please, I need you to pay attention. There's a difference between A and B. Oh my God. If you look at A is talking about Y, random variable Y. Y doesn't depend on anything. But take a look at B, even though they look the same. But there's a conditioner. This condition on S, right? Okay, I need you to pay attention right now on how this is going to be solved. If I want to solve a question that has to do with A, I'm only going to reckon with because they talk about Y. I'm going to reckon with this guy. Let me do this so that I don't confuse you. I'm focusing on A right now. I'm going to focus on that guy, and I'm also going to focus on this guy. I'm only going to focus on the mean and the variance that has to do with the random variable under investigation, because I'm only talking about Y, right? Okay, and I was told they follow normal distribution. That would be super cool, and that is the reason why I'm going to frame that in another way. I'm going to say, okay, you know what, instead of focusing on Y, I'm only going to focus on that. Y follow normal with mean of 110. Where do I get the mean? Is here 110. Why? Why? The variance of 100. Okay, take a look at that. One other way to write 100 is 10 squared. It doesn't matter. Okay, if I have this guy now, and I want to find this, then I need to standardize. If I want to standardize, okay, I want to standardize. Okay, so the probability of 106 less than Y less than 124, okay, will be probability. Now, I want to get Z for 106. I want to use Y minus mu of Y divided by standard deviation Okay, that will be 106 minus, what is the mean? 110 divided by standard deviation. The standard deviation is going to be 10 because the variance is 100. Okay, so here, 106 minus 110 is at negative 4 over 10. So what is negative 4 over 10? That would be negative 0.4. So here, I'm going to have negative 0.4. Then I'm going to have a z. Then I will do the same to this. So 124 minus 110 divided by 10. So what is that? 124 minus 110, is that 14? 14 over 10, and that is looking like a 1.4. Okay, this is 1.4. Okay, now the next thing to do is z less than 1.4 minus z less than negative 1.4. This is to, you check it from a normal table. Like I said, I'm going to provide a normal table, or the necessary table that you're going to need for the exam. When you do that, you're actually going to have this result. Okay, so this is like, I'm checking it from a normal table. Okay, I'm checking from a normal table and I got that result. So that is how to do that. Does that make sense? Now, how do we handle the conditional? Okay, here I'm focusing on y only. Now, how do we handle conditional? I'm going to show you how we handle conditional right now. Now, please pay attention. You know, when I was working with y, I did not use correlation, because I'm only focusing on y. Okay, but take a look at the next question now. Take a look at question B. Okay, but this time around, giving x equal to 3.2. The moment, it means I'm focusing on a conditional function of y given s. If I'm focusing on the conditional function of y given s, then I'm going to have a random variable that is conditional. I'm going to have a mean. I'm going to have conditional mean. I'm also going to have a conditional variance. Now, if I were you, okay, take a look at this now. This guy is now a random variable. But the one we did before, it was just y. That's a random variable. But right now, y given s equal to 3.2 is a random variable. Then I need to figure out the mean of that. I need to figure out the variance of that. You remember what we've done before. Okay, expected value of y given that. You remember this formula? I derived that formula in this class. If I were you, why can't you write that as part of what you're going to put on a cheat sheet? Okay, this is a conditional mean given s. Okay, the formula. What am I going to do? I need to derive that. I also need the variance. You remember conditional variance, because this is a conditional. Now I'm going to start plugging in mu y, sigma y, all of that has been given. I plug them in. They have been given in the question. I do the same thing for the variance. You know what I got right now? I got what I need. This is the situation now. This is a random variable. This is the conditional mean. This is the conditional variance. Then I'm going to go into z again. Okay? Now I need you to pay attention right now. Okay? If you take a look at this. Okay? I'm using y minus the mean over standard deviation. Where did I get that? That is a conditional mean and conditional that. Can you see that now? And how do I get negative 1.25? How do I get negative 1.25? To get a negative 1.25, I'm going to do 106 minus the mean divided by the standard deviation. You can try that now. 106 minus 116 divided by 8 is going to give you this guy. How do I get this? 124 minus 116 divided by the standard deviation. We also give you that. What do you have now? Just go to the table, normal table, check for 1.0, check for this, subtract them. In the exam, I'm going to give you a normal table that also have a negative. You know, this is a negative right now. Okay, so you just All what you just need to do, you do that, then you are right. Now take a look at this. Here we got 0.736, and in the other one, we got this. Are they independent? They are not, because this value here is not the same as this value. So they are not independent. Not independent, they depends. And that's why correlation exists. Does that make sense? Okay. Like I said, if you, let's say for instance, you spend your time on this particular